The question is, for a reaction, consider the plot between ln k versus 1 by t given in the figure. If the rate constant of this reaction at 400 Kelvin is 10 power minus 5 second inverse, you have to calculate the rate constant at 500 Kelvin, right? Now this plot is between ln k and 1 by t. Now according to the Arrhenius equation, we have k is equal to a e to the power minus ea by rt. A is the Arrhenius constant, E is the activation energy, R is the universal gas constant, and T is the temperature, whereas K is the rate constant, right? So if we take ln on both sides, we will get ln K is equal to ln A minus Ea by R T ln E, and ln E is 1, so we get ln K is equal to ln A minus Ea by RT. So the curve has been plotted between ln K and 1 by t. So therefore, if you compare it with the straight line equation, you get y is equal to mx plus c. So therefore, this is a straight line graph, but it has a negative slope, and the slope is equal to minus Ea by r. So basically, the value of minus Ea by r is given to you as minus 4606, right? So from here, the value of, or you can simply just say that Ea by r is equal to 4606. Okay, we will put this value directly in the formula. Now you are given that at temperature T1, which is 400 Kelvin, the value of rate constant given to you is 10 power minus 5 second inverse, right? Now you have to find out the value of rate constant at 500 Kelvin, right? You have to find the value of K2 here. Now we have this equation that ln K2 by K1 is equal to Ea by R 1 upon T1 minus 1 upon T2, right? This is what we have. Now we have to find the value of K2. K1 is 10 power minus 5 is equal to the value of Ea by R is 4606. Okay. Now 1 upon T1 minus 1 upon T2 can be written as T2 minus T1, right? T2 minus T1, which is 500 minus 400 divided by T1 into T2, which is 500 into 400, right? So when we will solve this, we will get K2 divided by 10 to the power minus 5 is equal to e to the power 2.303. When you will solve this side, you will get 2.303, and when we will remove ln from here, this will go into the power of e. Okay. So from here, we will get K2 is equal to e to the power 2.303 is actually equal to 10 into 10 power minus 5. So the value of K2 comes out to be 10 to the power minus 4 second inverse, and that's the correct answer for the question.
Hello guys, in this question it is saying that if a reaction follows Arrhenius equation and the plot between ln k versus 1 by rt gives us a straight line with gradient, gradient means slope, the slope of minus y unit, then we have to find the energy required to activate the reactant. Right, now we have also 4 options here. First option is minus y unit, second one is yr unit, third one is y unit, fourth one is y by r unit. Right, so first we will write down the Arrhenius equation here. So Arrhenius equation is k is equals to a multiply e to the power minus of Ea by rt. Right, now it is saying that the plot between ln k and 1 by rt, but we have only k here, so we will take both side ln. So taking both side ln, right? So this will become ln k is equals to, this will become minus of Ea by rt plus ln a. Now this is also saying that this will gives us a straight line. So this is a straight line. Now we will compare it with the standard straight line. So the equation of standard straight line, as we know, is y is equals to mx plus c here. So here we will say that y will be equals to ln k, x is equals to 1 by rt, because there is the graph between ln k and 1 by rt. So this will y, this is x, and slope m is gradient, which is slope. So m here we can see this will be equals to minus of Ea, minus e multiply a, and the c is equals to ln a. Now it is saying that the slope gradient is equals to minus of y unit. So as we know here, this is the slope and this is equals to minus of y. So m is equals to minus of y. We know the value of m here. which is minus of EA. So minus of EA is equals to minus of Y. Negative will be cancelled out by this one. Now EA is equals to Y here. What we have to find out is the energy required to activate the reactant, which means we have to find the activation energy. So this is our activation energy. EA is our activation energy. This is equals to Y. So this is the answer. Y will be our correct answer. So here we can see option number C is our correct answer. This is answer. Thank you for watching. Best of luck. Bye bye.
That for an elementary chemical reaction, A2 gives 2A. The expression for dA by dt is. So we need to find dA by dt, and we have 4 options. So let's solve this question. First we write our equation, which is A2 gives 2A. So rate of reaction is equal to change in concentration divided by time. So rate of reaction is equal to minus dA2 by dt. Here negative sign represent that A2 is decreasing with respect to time, and plus half dA by dt. And here positive comes because A is increasing with respect to time, and 2 represent stoichiometric coefficient. So now we have two equations. A2 gives 2A, and rate constant of this reaction is K1, and 2A gives A2, and rate constant for this is K minus 1. So now we can write rate of this equation. The rate is equal to K1 A2 concentration minus K minus 1 A concentration square because stoichiometric coefficient is 2. So now rate is equal to half dA by dt, so we can write half dA by dt. dA by dt is equal to K1 A2 minus K minus 1 A square. So now we can find dA by dt is equal to 2K1 A2 minus 2K minus 1 A square. So this is our answer. So let's check our option. So option 3 is correct one. Thank you.
The question is, the following results were obtained during the kinetic studies of the reaction. The reaction is 2A plus B giving products. You are given 3 experiments and concentrations of A and B and the values of rate. Okay, you have to calculate the time in minutes that is required to consume half of A. It means that you have to calculate the half-life. Okay. Now, if you look at this table that is given to you, what you are given, that in the first experiment, the concentration of A is 0.10. In the second experiment, also the concentration of A is 0.10, whereas the concentration of B is changing. But the rate is not changing. It means that when the concentration of A is constant, the rate is also a constant. It means that changing the concentration of B has no effect on the rate, which means that your reaction order of the reaction with respect to B is going to be 0, because we are increasing the concentration, but it is not affecting the rate. Whereas if we are keeping the concentration of A as a constant, then it is going to increase. Then the rate is constant only. So what do we conclude from here? If we write down the rate law, that is K into concentration of A to the power X, B to the power of Y. X and Y are the orders with respect to A and B. From the table itself, we understood that increasing the concentration of B has no effect on rate. It means that the reaction is 0 order with respect to B, which means that Y is equal to 0. Right. Now, if we talk about X, what do we observe? That when the concentration of A is increasing, right, when we are doubling the concentration of A from experiment number 2 to 3, right, we are making the concentration from 0.1 to 0.2, we are doubling the concentration of A. And if we talk about the values of the rate, right, the rate is also getting doubled. Okay, the rate is also getting doubles. It means that when the concentration of A doubles, the rate also doubles, which implies that the rate is directly proportional to the concentration of A. It means that it is first order with respect to A. So from here we have that X is equal to 1. So the rate law becomes K into concentration of A only. It does not depend upon the concentration of B. So this is very, very clear from the table itself. Okay. Now we have to find out the value of K first. Okay, so basically what do we understand? That this is a first order reaction, right? This is a first order reaction. And if we talk about the value of rate here, right, let us consider any of the experiment. So I am considering experiment number 2 here. So the value of rate corresponding to it is 6.93 into 10 power minus 3. We have to find K, and the concentration of K here is 0.1. So from here the value of K comes out to be 6.93 into 10 to the power minus 3 divided by 0.1, right? So this comes out to be equal to 6.93 into 10 to the power minus 2. And what will be the unit? Unit will be, they have given mole per liter per mole inverse. No, this will be minute inverse, right? This will be minute inverse. This is the unit of K, okay, for the first order reaction. Now you have to calculate the half-life, right? You have to calculate the time in minutes to consume half of A. So when half of A is consumed, it means that we are talking about the half-life. So half-life is equal to 0.693 by K. The value of K that is given to you is 6.93 into 10 power minus 2. I'm writing it in the numerator itself. Right now, the point will get the 3 zeros will come in the denominator, 2 zeros will go in the numerator. 693 will get cancelled out, 2 zeros will get cancelled out, and this again. So we will get 10 minutes. The half life is going to be equal to 10 minutes, and that's the correct answer for the question.